Characteristics of sound. Sound is produced in the environment by alternating pressure changes. Alternating pressure changes in the air. And is caused by the vibrations of solid objects or separation of fluid. Or separation of fluids as they pass over around or through holes in solid objects. These vibrations cause the surrounding air to undergo compressions and rarefactions. To undergo compressions and rarefactions. These are sinusoidal path like this. It's like this. This height is called amplitude. This is pressure in plus and minus directions. Pressure P. And this direction it is time. As time passes, the pressure will be positive and negative like this. This is zero pressure line. This horizontal line is zero pressure line. Zero pressure and positive pressure, negative pressure. And the time between two peaks is called period. This is called period. Period P. So many seconds. Okay. And distance scale also we can write this one. We can draw plus minus. This is 0. This is pressure variation. And this is distance. It's like this. So now peak to peak distance is called here wavelength lambda. Wavelength lambda. Now the relation between period and frequency. We know frequency can be defined as frequency F is defined as number of cycles per second. Number of peaks per second is frequency unit hertz. Hertz or Hz. Now, in 1 second, F cycles means the period P equal to 1 by F. In 1 second, for 1 cycle, time required is P equal to period P equal to 1 by F, because in 1 second F number of peaks will occur. That means per peak time required is 1 by F. And moreover, the relation between wavelength and frequency is wavelength lambda equal to see, distance equal to velocity into time. Velocity is c and time is time period p. So which is equal to c into 1 by lambda 1 by f. C into 1 by f, where c equal to velocity of sound wave. Velocity of sound wave. Then amplitude. Amplitude A. Amplitude A amplitude A. It is the height of the peak sound pressure measured above or below the zero pressure line. It is the height of the peak sound pressure measured above or below the zero pressure line. Zero pressure line. The equivalent equivalent pressure of such a sine wave, such a sine wave, such a sine wave is represented by root mean square pressure. Root mean square pressure. Root mean square pressure PRMS as PRMS equal to, first pressure will square it, that wave square it and integrate over the period 0 to t and divide with t, so that we will get average of squared value, and finally we will square root of having square root, we will get RMS value. PRMS, where P is pressure at time t, PRMS. The RMS sound pressure is thus obtained by the RMS pressure is thus obtained by adding the squares of amplitude values at small time intervals, and dividing the total by the averaging time and finally taking the square root of the total, this works out equal to A by root 2. If A is the amplitude, then its RMS value is A by root 2 for regular sine wave. The power of sound W is defined as power of sound. W. It is defined as the rate of doing work by traveling by traveling sound wave in the direction of the propagation of the wave. Propagation of the wave. The intensity of sound intensity. Sound intensity I. It is defined as the sound power averaged over the time. Sound power averaged over the time per unit area normal to the direction of propagation of the sound wave. Propagation of the sound wave. That is I equal to W divided by area A, normal area. It is also related to I is also related to PRMS. I equal to and sound intensity I is also related to PRMS as below. I equal to PRMS square divided by rho into C, where rho equal to density of air, or medium in kg per meter cube. C equal to velocity of sound in meter per second. Now levels of the noise. Levels of the noise. The sound level L equal to, it is in log scale basically, log base 10 Q divided by Q naught bells. Q naught bells. Q divided by Q naught bells, where Q equal to measured quantity of sound pressure or sound intensity. Q equal to where Q equal to measured quantity of sound pressure or intensity. Q naught equal to reference sound pressure or intensity. Instead of expressing this into bells, it is convenient to express in decibels. So L in decibels in dB equal to 10 log Q by Q naught. Now sound pressure level. Sound pressure level LP in decibels. So LP is expressed as LP equal to 10 log PRMS by PRMS divided by P reference, that is 20 micropascals whole square, because energy is related to PRMS square. That's why square we are taking here. It turns out LP equal to, the 2 comes here, 20 log base 10 is all base 10 only, 20 log base 10 PRMS by P reference, that is 20 micropascals. Otherwise we will write like this: PRMS by P reference, where P reference equal to 20 micropascals. This is the formula for sound pressure level. Then sound intensity level. Sound intensity level Li in decibels. It is Li equal to 10 log base 10 I divided by I reference, that is intensity, where I reference equal to 10 power minus 12 watts per meter square. 10 power minus 12 watts per meter square. Some points here we'll write. Sound intensity varies as square of the sound pressure, square of the PRMS. That is one thing. And next point here, it is an increase of 20 decibels in sound pressure level will correspond to the PRMS sound pressure PRMS or loudness of sound, increasing by 10 times. Number 3, 1 decibel is the faintest sound which can be perceived by human ear. Or around 25 micropascals is the faintest sound pressure. Which can be perceived by human ear. Number 4, the maximum sound which can be tolerated by human ear is 180 decibels. Then the loudest sound produced by produced by a Saturn rocket. A Saturn rocket at the liftoff stage. At the liftoff stage is about 200 pascals. 200 pascals. Pascals means it is about, in sound pressure level, 200 by 20 into 10 power minus 6, that is, it is level is actually 20 log base 10. 200 pascals means 200 into 10 power 6 micropascals divided by 20 micropascals, which is equal to 10 power 7 here. So around 140 decibels. 140 decibels.